this session, we're going to talk about how to optimize building software in your organization and measuring its impact. When you're a small startup or a team, you can often navigate the day-to-day and the week-to-week by feel or intuition. Are we shipping? Do things feel fast? Do they feel slow? What's each person on the team accomplishing? I really encourage keeping things as simple as you can while you're small, and it's easy to see everything that's happening right before your eyes. But as you grow, eventually the unit for accomplishing engineering work becomes primarily the team, not an individual person. And how do you tell how effective those teams are being? And how do you optimize their execution to ship better product faster? Over the next few minutes, we're going to find out and dive deep into this topic. A little bit more about teams. Each team needs to be large enough that you can think of their work as a unit. A team is an abstraction. In engineering orgs bigger than 20 or so people, teams get the work done. I found that 6 to 8 folks is a good size to work with. Any smaller, you end up having to think about who's out on vacation or sick in order to reason about the work getting done, which breaks the abstraction. Bigger, and the cohesiveness of that team breaks down. There's too many people to hold effective meetings and just too many relationships to build between individuals. We're going to ignore planning and goal setting because you've already heard sessions on those topics in this series. You've got goals and you know what to build. Let's optimize the building process. First, we're going to take a look at the execution piece, starting with optimizing cycle time. And later we'll talk about the metrics that you can look at to measure impact once a new code, feature, a change is in production. All right, let's dive in. Building software is an engineering process, and over the years, we've managed to steal ideas from other engineering disciplines, particularly manufacturing, to reason about how to optimize building software. If you think about building software as a pipeline of steps, it looks like this. Depending on your particular software domain, there might be extra steps in there, such as QA, load testing, or some other things. But we're going to focus on this simple life cycle for now. Each step takes a certain amount of time, and the total cycle time is the amount of time between starting the work and the work being delivered. Work needs to be delivered in order to create value. And in our field, delivering work in smaller chunks tends to work better overall. That's because the larger and more complex a code change is, the more likely it is to contain bugs, performance problems, or other unintended impacts. And the harder it may be to isolate problematic code and remove regressions. And generally, you want to get to a point of getting feedback quickly. That's overall easier when you ship in small increments. So if getting code to production is the first opportunity to see real value, overall, we want to minimize the amount of time it takes to get from design to production. And since we're engineers and we have a series of steps, a natural strategy is to optimize those steps, just like we're optimizing a slow piece of code. All right, so there's 3 steps we're going to dive into first. The first one is super simple, measure. Second, optimizing those steps. And 3, optimizing overall the feedback cycle and getting to a place where we have happy engineers. For step 1, measure. The big picture here is that you want to instrument your cycle so that you can see how long each step takes. And this is a prerequisite to the second bit, which is optimizing those steps. This really doesn't have to be complicated. If you're using GitHub, you can get a lot of this data using the GitHub API. For things like test runs, whichever continuous integration runner that you're using, whether that's GitHub Actions, Circle CI, Travis, Jenkins, etc., should give you that data. The quickest way to get started can really just be to benchmark each step and grab those numbers in just a one-time grab. You don't need to get caught up in having statistical data for a large amount of time. And if that's difficult, just skip it. That one-time sampling can really be just enough to figure out where your bottlenecks are. All right. The next step is to optimize the slow parts. I'm going to cut straight to the chase here. When debugging production issues, it's off the database. Well, When debugging cycle time issues, the problem is often how long your tests take to run, or how long your deploys take, or how reliable they are. These are often the places to start when debugging cycle time. Writing code, well, this amount of time can vary widely from engineer to engineer, and that's a primary growth point for individual engineers. But when placed in the overall context of software engineering delivery, it's usually not the place where the most time is spent. A second common place to look for room is to optimize is in how many bugs you end up shipping to production, and you end up having to roll back because it's a regression, or you have to create a hotfix and roll forward to a new build. This is known as the defect rate. If you think back to the diagram of the cycle, you can see that every bug identified after being shipped to production is very expensive because it makes you start right back at square one of the cycle. Hopefully, it's not as hard to fix a bug as it was to initially create the code change, but it's going to require going through each phase of the cycle again and incurring the costs of building, testing, and deploying a software artifact. So if you can reduce the number of bugs that make it through to production, your shipping velocity should go up. And not to mention, you're going to have happier customers seeing fewer bugs. How do you fix this? Well, it might involve increasing your test coverage, or maybe investigating more sophisticated testing strategies such as replay testing if the testing that you're able to do is not catching enough bugs before they go to production. A third place to look is code review. Do pull requests hang around for days before getting attention from another engineer? This can be a huge drag on velocity. Measure this, report on it for each team in the organization, and if this time gets much longer than a business day, the team's manager should really investigate and figure out how to resolve that bottleneck. Code review is an important means for information and best practice sharing, and it can reduce or find some bugs before they get shipped, but it shouldn't be a huge bottleneck on the development process. I want to make a quick aside here about tools. You may want to invest in some additional tools that can help you get some insight into these pieces of the development cycle. A couple popular ones are, one is Pluralsight Flow, another is Code Climate Velocity. And these tools can help you visualize things like how long pull requests stay in each state, and a few other interesting metrics, such as new code versus changes to existing code that are going into your code base. These tools are most useful when you have more than 20 engineers, a few different teams, and you can justify the cost of buying those tools because it's offset in the time that you save building this tooling for data analysis. All right, step 3. What makes a happy engineer? Having a super fast feedback cycle. And in today's modern systems, often some amount of feedback can only be obtained in production. So the total lifecycle length is very important. You want to be able to ship multiple times a day to production on the same app or service. But there are also other ways to improve the development process to speed up the feedback cycle. One example is in the testing part of continuous integration. It's common to include some linters or static type checking as a part of the CI process. Are some of those fast enough to run locally? You might find a lot of benefit from using a tool like Pre-Commit to run them on developers' laptops before pushing up and kicking off a CI run. This will make it so an engineer can fix linter and type errors in seconds, rather than however many minutes it takes your CI to run. And you also get rid of a context switch, so an engineer doesn't have to change screens from their development environment to the CI and back again. The flip side is also true. Tests are often faster to run remotely and parallelized than on individual developers' laptops. If you make this happen primarily as a part of CI, code review can start in parallel before the CI test run is complete as well. What's a good overall cycle time? Best in class would be something like 15 minutes to ship a one-line hotfix through to production. For most larger systems, you're probably looking at something longer. The overall aim, again, is to make shipping multiple times a day easier. That's the big picture goal. At some point, once you have a handful of teams, it's probably going to make sense to invest in a small team of engineers whose primary focus is on internal developer tooling or creating leverage and optimizing cycle time across the organization. While this overhead doesn't go directly towards shipping customer-facing product, it's easily made up for in productivity gains for the engineers who are. So we've talked about measuring and optimizing the execution piece of software delivery. And now we're going to take another step and zoom out and talk about what happens once you have that new product, new feature, new performance change, refactor in production. How can you assess its impact? Now, I come from a background in enterprise SaaS, so my answers here are going to be a little bit skewed in that direction, but much of this should be applicable across business types. We're all building software because we want to accomplish something with it. In the case of a business, the simplest possible measure of impact is revenue. However, it's not always possible to tie back every feature or change to a change in revenue. I've aggregated a bunch of examples here of ways that you might measure the impact tied to a change, and we're going to go through them right now. Again, the simplest possible way to measure impact is by tying it to revenue. If you're shipping a new product that you're just charging for, this is really easy. You can just measure the amount of money that you're making through that new product. But new features can also have revenue impact. For example, if a feature is tied to an upsell to a higher level tier of plan, you can measure the change in upsell revenue before and after that feature was launched and figure out the revenue impact of the feature. It's also often the case that sometimes you have features that are given away for free as a part of the overall package. And in that case, you may want to measure the usage or engagement with that feature as a part of the engagement of your overall product. Another way to measure impact for certain types of changes is on reliability, especially when we're running services today. That might manifest as an increase in uptime. Maybe you have a higher success rate because changes fixed some bugs or made it so that your system scales better. This can also manifest as a change in support ticket volume that folks are writing in about problems in your product. If you're fixing bugs or you're making the product more robust, that should hopefully at the end of the day mean that there's less support load for your team. And another way to look at this is also, if you're creating tooling internally, if that helps your support team resolve tickets faster, that can be a great way to measure impact. Another piece here is performance impact. So measuring, for example, the percentile time for API requests or various different operations that happen in your system. Also queue wait time. Another piece is cost impact. So, we're building businesses here, and the amount of money that a business makes minus the costs of actually serving and creating that product is overall the performance of the business. So cost is a huge part of that. So if you're able to measure the cost improvements of a change, that is a huge impact for the business. Lastly, also wanted to mention your inbound funnel, which is something that's super important, especially when you're making changes to a website or kind of the front end pieces of things. If that results in increases in signups or increases in folks reaching out to your sales team wanting to buy, or the time to convert a customer through a self-service buy flow decreases, those are huge impacts that you can bring back to the business and show that this code change, this development time was well spent. The key here is really that your code solution should tie back to a business goal and should be able to be measured by some metric. There's obviously tons of different types of these metrics, and these are just a few examples. All right, we made it. Let's sum things up. If there are just 3 things you remember from this session, it's these. 1, care about and measure cycle time. Overall, this is the key to optimizing the execution aspect of software delivery. Number 2, fast feedback makes happy engineers. Anything you can do to reduce the feedback cycle is going to make your development teams more effective, and it'll improve morale too. Number 3, make sure to identify and track metrics around business impact. At the end of the day, we're building software to accomplish business goals. Measuring the impact of a new feature or a change allows you to get feedback on whether or not you built the right thing in the first place. And later, you can use that to help plan better for the next iteration. Thank you very much, everybody. It's been a pleasure to spend some virtual time with you all. I hope you learned something, and if you have any questions, please feel free to get in touch.